week in our course, of course, we're talking about drug discovery and development. And I'm very pleased to have with us a very prominent scientist. And we'll be talking with some other folks this week as well to help us to understand the things that we've talked about theoretically in our content videos, to understand kind of in a more practical matter how that plays out in a lab. This is an exciting part of our course. So, this is Dr. Robert Brueggemeier. Bob, we appreciate you being here.
Glad to be here.
Bob is a professor of medicinal chemistry and pharmacognosy in our course, and we've learned what those disciplines mean. And he was just recently actually dean of our college. So Bob has worn many hats in his distinguished career. It's a real pleasure to have you with us.
Thank you.
So Bob, as we start this discussion about drug discovery, I'd like to ask you to begin by just telling us how you prepared yourself academically and research training and all that to get to this point.
Sure. Well, I started as an undergraduate, really interested in undergraduate research. I was a chemistry major and got involved in some organic chemistry research as an undergraduate. And as I was kind of wrapping up my undergraduate, I was trying to think of where I wanted to go with my career. And I had interviewed with some pharmaceutical companies as an undergraduate, and that perked my interest in the area of medicinal chemistry. And then after undergraduate, I decided to go on to graduate school in medicinal chemistry and receive my master's and PhD in that area, particularly focusing on steroid chemistry and biochemistry. And then following that, went on a 2-year postdoctoral research position in the area of steroid biochemistry, and then came to Ohio State 34 years ago as a young assistant professor.
That's right. And it's been a long story since then.
That's right.
Good story.
Yeah.
Well, Bob, I think the heart of the matter here for us today is you're a guy who has been in a lab doing the exciting science, the discovery, and you have been very involved in developing some of the early work in developing these drugs called aromatase inhibitors.
Right.
And these are used in breast cancer research, and you know that's been a huge accomplishment. Can you walk us through that? Like, how,
Sure.
I mean, how did you figure out these compounds were effective, and how does that happen on a practical basis?
Sure. Well, I was always interested in developing drugs for treating cancer. And being in the area of kind of steroid chemistry and biochemistry, obviously hormone-dependent cancers are cancers that rely on the hormones for their growth. So breast cancer, prostate cancer are 2 examples of that. So I was very interested in developing agents to treat breast cancer, and I became interested in this enzyme called aromatase. It's an enzyme that our body uses to make estrogens, and estrogens are made both in males and females, but more in the female during reproductive period of life. And this is a very interesting enzyme. It takes molecular oxygen and converts it into a form that then acts on the steroid molecule to hydroxylate it, and in the end converts an androgen to an estrogen. So I was very interested in kind of the basic biochemistry of that enzyme, and then developing inhibitors. And the way we approached developing inhibitors was sort of a classical medicinal chemistry approach of taking a known substrate, testosterone, and modifying it chemically to see if it would inhibit the enzyme. So that's how we began. We're making molecules that were derivatives of androgens, and we happened to be very fortunate to pick a right position chemically on that molecule that ended up being developing agents that were very effective inhibitors. And so we got started in that, and over the years we've also been involved in what we call non-steroidal inhibitors as well, inhibitors that aren't based on the steroid, and yet targeting that enzyme. So that's how we got started, and most of the early work involved graduate students and undergraduates in the laboratory making compounds and then testing those initially in enzyme systems that had the enzyme aromatase, and then eventually in breast cancer cell cultures that also express the enzyme aromatase and would look at the ability of these compounds to inhibit it. And then as we developed some very potent compounds, moving those into preclinical animal studies to demonstrate that even in vivo these molecules would suppress hormone-dependent breast cancer growth. Yeah. So it was very exciting, an involvement of undergraduates and graduate students and postdoctoral researchers in the laboratory. The whole area of aromatase inhibitors really developed out of academia, and there were several labs in the U.S. and primarily in the U.S. and Europe that were involved in this work. And we would meet every 3 or 4 years and share our research and recent findings. And that was during the 80s. And then in the early 90s, a drug that was on clinical trial for another use had a side effect of blocking this enzyme. And all of a sudden, it seemed like all of a sudden a lot of pharmaceutical industry became involved in developing aromatase inhibitors. And then by the mid to late 90s, there were several that were in clinical trials. And in late 1999, 2000, the 3 of those agents that came out of those clinical trials came to market. And it was a very exciting time being involved in, really from the beginning of the development of this class of drugs to the introduction of a new class for treating women with hormone-dependent breast cancer.
It's got to be thrilling.
Oh, it's very exciting to be through to really live through that era.
So
very
you
exciting.
really talked about kind of modifying molecular structures.
Right, exactly.
Finding side effects in other agents that had an effect that you're looking
Right.
for. You've identified the target. So then it's kind of like just basic chemistry as you described it to
Yeah, really.
modify and-
Chemistry and sort of preclinical studies is which most of us in academia have been involved in. And then once some novel molecules were identified, our colleagues in the pharmaceutical industry really took that ball and ran with it and developed their own agents and clinical trials and supported the clinical trials that were run again by many of my colleagues around the country. To really demonstrate that these are effective in treating women with hormone-dependent breast cancer.
Now, Bob, as you were just defining your academic training as we started this discussion, you mentioned that you worked as an undergraduate in a lab.
Right.
And so can you give us an example of all this cool work that you did through these years, maybe of an undergraduate that contributed to that? Because I'm guessing there may be people out there who are doing the same thing.
Well, one of my first undergraduates in my laboratory here at Ohio State was an individual named Kathy Snyder, who was an undergraduate in our pharmacy program. And she was interested in a research project and came and talked to me. And I had just started a year or so before that. And she was very interested in this research and started being involved in making initial compounds and then testing those compounds in the enzyme. And ended up with, as an undergraduate, a couple of publications. She then decided to go on to obtain her PhD, and after looking at a number of schools, decided to stay here at Ohio State. So she ended up being my first PhD graduate as well. And then finished up, did a couple of postdocs, and then was at Procter & Gamble for many years in research. So that's just one example. I've had students from pharmacy, students from biology, biochemistry, that have gone on to various careers, either research or PharmD programs or MD programs, and are practicing professionals.
It's a good place to start.
It is a good place to start, and as I tell lots of undergraduates, when you're an undergraduate at the university, you've got some flexibility to try some things out, and sometimes it works great, and sometimes it doesn't, but you've learned in that process. And over the years, I probably had twice as many undergraduates who've gone on to other careers and undergraduates who've stayed in research.
Figure out what you like and what you don't.
That's exactly right. And the time to do that is as an undergraduate. You're really exploring career options.
Now, Bob, you've had, as we've described, a long and distinguished career in pharmaceutical science in general, drug discovery in particular. I'm just curious, as you look back and maybe as you look ahead, things must have changed pretty dramatically in how drug discovery and development works. Is that true?
That is true. And for many years, it was pretty much the molecules that came out on the market were really driven by the pharmaceutical industry. As we have begun to tackle more complex diseases, chronic diseases in particular, it's not as easy to identify kind of major blockbuster drugs anymore. And so what we've seen is a significant change in the pharmaceutical industry from that basic drug discovery to now more drug development and partnering with individuals at academic institutions like Ohio State for that early drug discovery and identifying leads and then moving those into preclinical studies. So it's shifted dramatically in the industry. I think part of it has been an economic model that's driven it. But the other part is as I say, the low-hanging fruit have been solved.
Yeah.
The easy targets and easy drugs have been made, and now we're into very complex diseases with multiple pathways, and it's going to take a combination of drugs to really impact those diseases. And so it's much more of a collaborative kind of team science approach that we're now seeing in biomedical sciences, and particularly in drug discovery, drug development.
So we've talked about a lot in this course about collaborative practice.
Mm-hmm.
We also have a collaboration research for sure.
Oh, for sure.
And then
Definitely.
Bob, just finally, there may be people watching this video that are at various parts of their life. Maybe they aspire to do what you've done. Any kind of last shot advice that you would have for them?
Sure. Well, I think first find your passion, and whatever you're going to be doing, you want to enjoy what you're doing, and that is find your passion. And if your passion may be in the area of drug discovery, drug development, get in a laboratory and get some experiences and find out if, yes, that is what drives me and I'm excited about that. And then, there are lots of opportunities, whether it be in academia, or industry, in government institutes, such as the National Institute of Health. There are many, many venues to pursue. But first, find that passion and get a little bit of experience.
Good advice. Well, Bob, congratulations on all you've done.
Thank you.
We really appreciate you being a part of our course.
And I'm glad to be a part of this course. Thank you very much, Ken.
Good luck to you.
Thanks.